Hello, I'm Tanmay Pandaru, and I built a surveillance ranger for my final project for IFT 598 Internet of Things. So this is my surveillance ranger. So I would explain you the components of it. This is practically an RC car, and I got hold the control of the motors using the L293D motor driver chip, which gives me the power to control its direction and its spin clockwise and anti-clockwise of the wheels, which is powered with a 9-volt battery. And then I'm using an Aurdino Uno for the brain of this chip. It is also connected to ultrasonic sensor, which is used to detect any obstacles and gives us the nearest distance between an obstacle and the starting point of the ranger. And I also have a ESP32 cam. This is a Bluetooth, this is a Wi-Fi module. This directly connects to my local server, which is my PC, and all the feed that goes hinges from here. And I also have a Bluetooth module, which is how the entire RC car is gonna operate on. I have an Aurdino IDE, which has the Bluetooth controls. We have if it has to go to forward, if it has to go backward, left or right. And this is all sent by a Bluetooth serial monitor, as you can see right here. This is a Bluetooth serial monitor. This is how the commands get passed on. And I have Aurdino code for the web server, and this is for all the ESP32 cam. And when I run that, this is the interface, the web interface that I get. So if I hit on, let us say, start stream, so as you can see, this is the stream that is coming out of the camera right now. Yeah, you can see there's always a latency, which is one of the most important challenges. And also this project comes under an IoT level 2 system. It comes under sensing and monitoring. With few upgrade, it can be categorized as IoT level 3. But with the now tech components that are present, it comes under IoT level 2. And I call it the surveillance ranger. The reason we built this project is, there's a flexibility and mobility challenge when compared to traditional surveillance systems. This gives us the advantage of being the flexible and mobile. So the main purpose of it goes to terrains where it beats the traditional surveillance systems. And the way it goes is, I'll explain you the control flow. We pass the command to a web interface to the RC car, and let us say if it comes and comes across an obstacle, and if we still press the command, the ultrasonic sensor you just overrides the function. It stops the wheels. And then we have the camera detection sensor, which I afterwards use a system called YOLO. You only look once. It's version V11, and I perform this particular thing on the stream that I get from the camera module. And let us start by running this script. So I'm running the script. It's gonna take some time. Yeah, see, now I'm getting the stream straight out of the camera module, and now where the ML OpenCV and YOLO is being performed. And if you see now, if a person enters into the camera frame, see, there's a person, right? So I've scripted this. If the camera finds it, if the window of the person box is more than 70%, I use AWS, a simple email sending service, which goes and sends me an email. So right now the time is 11:11, and you can see I've just received an email 11:11, and if I open it up, I see a person was detected at given the timestamp, the time, and the estimated distance, and the picture along with it. This is where I'm using the cloud component to alert the owners of the system if there was a presence detected, or if trained for any objects or things detected. So we also try to use Amazon Kinesis video streams, where this live feed is directly streamed into AWS, but because of latency issues, it was not viable. But with the better hardware, definitely this is a win-win project, and there's a lot of future scope, just making it completely autonomous. And also, let me give you a short demo of how the RC is gonna work. So if you can see the wheels moving, right? So this is how I'm gonna operate, and the instructions are getting passed through a Bluetooth serial monitor. Just a second. This is where I control the opposite spin. This is going anti-clockwise, which is back. This is going clockwise, which is forward. And this is how I control both the wheels. Yep.